So the undergraduate competition has two prizes. The first prize is a $4,000 grant to the winning team. Second prize is a $2,500 grant, but each of the two winners is advanced on to the CMU Venture Challenge, which will be held this weekend and is hosted by the Undergraduate Entrepreneurs Association. I have a surprise for you. The next company is not AI based. Can you believe it? No, I'm lying. No, I am not lying. They are really not. So the next team is KnitFit. They've come up with unique new ways to create compression garments.
Almost 60% of hospitalized burn patients every year are children. By the time the custom fit medical compression garments prescribed to treat their burn scars finally arrive 1 month after ordering, the child has already outgrown them. We are KnitFit. I'm Asta, the CFO.
I'm Advika, the COO.
And I'm Pratyay, the CEO. And we're looking to create custom fit medical compression garments 10 times faster than current vendors. Currently, the compression garments industry faces a critical trade-off between fixed size garments that don't fit most patients well and custom fit garments that take too long to deliver. This results in either ineffective or delayed treatment for patients with pressing medical concerns, such as in the situation described by Asta earlier. We're solving this using an end-to-end automated approach, at the core of which is research that was developed at CMU's Textiles Lab, which involves a programming language that allows us to take inputs and generate custom machine files to knit these garments on demand in half an hour and deliver them much faster than the 1 month that current vendors use. We also hope to incorporate photogrammetry to pull patient measurements from scans to make the entire process automated. So these are some of our latest prototypes. We're working on creating both compression socks that treat deep vein thrombosis and lymphedema, as well as compression gloves, which are worn to manage burn scars for a year after the wound. And both of these devices are FDA Class 1 exempt, and they don't require any regulatory approval. And the IP will be owned by us for the algorithm that generates these files. The advantage we have over our competitors, the main advantage we have is that we produce both custom fit and on demand. And you can see a couple of the gloves, which I'm wearing right now. So the KnitFit glove, which is here, provides even compression throughout and has completely eliminated seams, whereas the BioConcepts glove, which is the current state of the art, has these seams, which are uncomfortable for patients. And there's weak compression on the palm due to bridging in a natural hand position.
As we look to bring KnitFit to market, we will begin by launching in the North American compression garment market, an opportunity worth $1.5 billion. As we see that our product gains traction and helps improve patient treatment outcomes, we will expand our product offerings globally in a market worth $3.5 billion. Finally, our TAM is the global compression products market at $6.5 billion. This includes tech-enabled medical compression garments, which is part of KnitFit's long-term vision. KnitFit's business model involves doctors prescribing our product to patients. Then patient insurance will cover the cost of our compression garments. For instance, currently, a basic Medicaid plan covers 8 compression garments per affected body part each year of a lymphedema patient. We look to price our product competitively at $120 to encourage adoption by doctors, patients, and insurance providers. Finally, in order to strengthen our research and development, as well as our initial production of our product, we will need to have a Shima Psyche knitting machine. We are already in conversations with the manufacturer who has an available resale machine for $13,000.
We believe that our team has the right experience to take KnitFit to the next level. Most notably, our CEO is a researcher at the CMU's Textiles Lab, and he's one of the few people that knows how to do garment manufacturing using KnitOut, the programming language behind this technology. Additionally, the rest of our team encompasses expertise ranging from business, operations to tech, allowing us to refine and scale our product to the next level. We also have a strong group of advisors with two notable faculty members, Dave Mawini, who provides us startup and business expertise, and James McCann, who's pioneering the research behind our technology. We're also working with doctors and textile manufacturing experts to help produce our product. So join us at KnitFit, where we're tailoring wellness and modernizing healthcare.
Can you explain a little bit more about the equipment required to make the garments, the measurements, and your vision for where these machines will live? Are they going to be on location in a hospital, for example, how that would all work?
Yeah, so the machine required is an industry standard knitting machine that comes from a Japanese manufacturer, Shimaseki, and is used by current clothing companies such as, Uniqlo. And for the scanning, we can do it on simple like iPhone devices with LiDAR cameras. So the iPhone Pros have LiDAR cameras, and that allows us to get detailed measurements. So we would when we're scaling, we would either use contract manufacturers or we'd have an in-house manufacturing facility, but it would have to be in one location and not at the hospital, because the current machine we have available for resale at $13,000 is much cheaper than the regular price of $80,000.
I have
So-
I'm sorry. I have two quick questions. We'll
Yeah.
try to make them quick. Number one, I just wanted to understand what you were actually disrupting with the garments. Is it the seams? Is it the fact that they expand with the patient? Like what's the real technological disruption?
Yeah, so it's mostly the time saved. So currently, if like this glove took a month and 10 days to get to me, and this can be done in half an hour. So it's just the time save, and that ensures that the patients receive their care in a timely
Okay,
manner.
perfect. And then the follow-up would be, how do you actually reach the patients? So the patients find you, or are you going through like a direct medical equipment supplier? Or how do you get to the
Yeah,
patient?
so currently the doctors prescribe the garments and they're sent to, their measurements are taken and sent to the manufacturer, and then the manufacturer delivers these garments. Yeah, we would be delivering these garments. So we'd manufacture them and then deliver them. Yeah.
And the $120, is that comparable to existing products? Everything's $120, or is that sort of a range?
It's mostly a range. So of course, depending on the product and the amount of compression, it could vary slightly, but generally the compression garments cost about $130.
And how does that compare to current products in the market?
Current products cost about $135.
Two quick questions. What do you expect your gross margin to be at the pricing that you've targeted? And do you see other healthcare needs such as diabetes or other areas that the compression garments are in demand?
Yeah, so for your second question, there are arthritis patients also wear compression garments. Breast cancer patients also wear compression garments, and these range from sleeves to face masks, knee braces, etc. So there are a wide range of applications. We're just focusing on gloves and socks for now. And for your first question, it's quite hard to estimate right now, but the cost of running the machine and the actual yarn cost is very negligible. So our main cost is just the machine that we have to buy.
How do you intend to educate the medical community that you exist, right? Oftentimes there are rebates or things to get a new drug into the market, right? So what have you thought about that go to market?
Yeah, we plan to attend, medical innovation conferences around the country and promote our product there, and get references from doctors. So we're already in talks with burn center doctors and vascular surgeons, and then referrals through them.
Yeah, just to add on to that real quick, we have advisors that have been working on that we've been working with directly to iterate on our product. So because we've had that approval and that support from doctors, we feel that this will naturally kind of initiate into patient relationships as well as just relationships within the medical community.
Have any of those advisors agreed to work with you on a pilot?
Yeah, so Dr. Rajesh Tharmaraj has already agreed to work on piloting the compression socks starting this summer.
I have one more question.
Is there anything you can do that the competition can't do in terms of taking the glove to the next level, like putting creams inside it or having it basically be a carrier of some kind of medical treatment as opposed to simply be a glove? And I just wonder if that's a consideration.
Yeah, so that's a good point. We haven't thought about it too much, but the technology allows us to be really flexible with our pattern. So I programmed this from scratch, so I can make any changes required by the doctors to fit in a pocket maybe to hold a cream or something. That's all possible.
Yeah, we have to stop there just to be fair to all teams. So thank you very much.
Thank you.